Hi, welcome back.
Konnichiwa.
Konnichiwa. Oh, it's morning. I'm sorry. Ohio would be good morning. So good morning. Welcome back. We are taking some time to continue on our right triangles. We've done a lot of work with right triangles, right? We use the geometric mean to help us find shortcuts when we had a bunch of right triangles all stacked up on each other. And then we use Pythagorean Theorem to find more stuff about triangles, right triangles, when they weren't stacked up on each other. And you remember on a couple of these, we had answers that had all these weird square roots in them? And a lot of you are going, oh dear God, please make this easier. I can make it easier for two special kinds of right triangles. Can't make them easier for all of them, but for two of them, I can. So here are your shortcuts, your special right triangles. The diagonals of a square, so I have a square, I'm going to draw it right here. Here's a square, a very ugly, not drawn properly square. But the thing to know about the square is that all of the sides are congruent and all of the angles are 90 and it's a square. Well, if I take the diagonals of this square, they're going to form two, congruent. They're the same size and the same shape. Isosceles, because the legs, you've got two congruent sides. Right, because there's a right angle. Triangles. That is a lot of adjectives. Two congruent isosceles right triangles. Since the base angles of an isosceles triangles are congruent, the measure of each of these acute angles right here, this one here and this one here, what would those measures be? 45. Because I already have 90 degrees taken up here. All told, these three have to be 180. So 180 minus 90 is 90. So I have 90 left for these two. They're both the same, and they add to 90. 45 is the only number that adds to itself and gives you 90 degrees. What are you looking for? A white piece of paper? I have one that's got writing on the front.
Oh, no,
I don't have one that I can get at right now. So later. Thank you. So yes, I have some just later. Okay. All right. We call this half a square, a 45, 45, 90 right triangle. And it's one of our special ones. So in this 45, 45, 90, the legs are congruent. Duh. And the hypotenuse, which is h for hypotenuse, which in our Pythagorean theorem was c, our hypotenuse is square root 2 times the length of the leg. Okay? Let me prove it to you. Let's go into the Pythagorean theorem, and let's prove to you that the hypotenuse really does do that. Okay? So that way we can get a feel for this, and then we'll do our shortcuts, and it'll be easy. All right, here's our proof. All right, we're going to start off with a squared plus b squared equals c squared. I'm going to use this triangle here, but for a moment, I'm going to pretend that I have no idea what the hypotenuse value is. Okay, I just see a right triangle with side length L and side length L. All right, so this is the hypotenuse, so I'm going to keep that as C. And these are the two leg lengths. One is A, one is B. And I'm writing my L's kind of cursive-y so that they don't look like ones. Are we okay with that? All right? Okay. All right, so now I have 1L squared and 1L squared for a grand total of? How many L squares do I have? 2. So I'm going to write 2 L squares. Now, I'm interested in the value of the hypotenuse. which is just the value of c. So how do I undo a square power? Take the square root. Beautiful. So I'm going to take the square root of both sides. My right-hand side is easy to simplify. My left-hand side looks crazy, so I'm going to write the whole thing and then look at it. I have a radical where inside there's a multiplication. That means that I can break the radical at the multiplication. So I can end up with 2 squared times, the square root of 2 times the square root of L squared. Do you want me to just rewrite that line because it's messy? Because it looks weird? Yeah? Okay. So I'm breaking it here. I end up with the square root of 2 times the square root of L squared. Okay, that's much cleaner. Nothing I can do about square root of 2. Not going to turn it into decimal. Going to leave it as square roots. Now I'm going to look at the square root of L squared. How do you undo a square power? Square root. I have a square root of a square power. This square root and this square power are going to undo each other, leaving me with just that thing inside. And because multiplication can be written in any order and having a square root in front is kind of weird and bizarre looking, we're going to rewrite it with the L in front. And that's it. Feel convinced now that this will always work? Okay, this will always work as long as it's a 45, 45, 90 right triangle. If it's any other kind of right triangle, this pattern will not work. Okay? So again, the pattern is, if you're finding the hypotenuse, take the length of the leg, multiply it by square root 2, you done. Okay? Okay. 45, 45, 90? Yes or no? Yes, this is a 45, 45, 90. What is the length of a leg? 8. And so the length of the hypotenuse is 8 times the square root of 2. Please don't put this in your calculator and give me a decimal. Just write 8 times the square root of 2 and call it done. That's it? That's it. You want to see it again? Is this a 45, 45, 90 right triangle? Yeah. Yes. What is the length of a leg? 4. And so the length of the hypotenuse is? 4 times the square. Which you're going to write like this and be done. It's like we're cheating. Bless you. Okay, we're going to look at number 4. 45, 45, 90 right triangle? Yes. Do we have the length of a leg? No. No. We have the length of the hypotenuse. When we had the leg, how did we get the length of the hypotenuse? We multiply by the square root of 2. So if I have the hypotenuse and I want the leg, I should divide by the square root of 2. So I'm going to do that. I'm going to take 16, which is the hypotenuse. I'm going to divide it by the square root of 2. Are you allowed to leave your answers with radicals in the denominator? No. Are you allowed decimals? Not on this assignment. No. Which means we have to rationalize. We're going to use rationalization. So we're going to multiply this fraction by some other fraction where top and bottom are the same. And we need to look at the denominator to figure out what we're multiplying by. We want to turn the square root of 2 into the square root of something that has a whole number square root. 2? Okay. So we're going to multiply by the square root of 2. This is a fraction times a fraction, so you multiply straight across. Please remember, cross multiply is only when it's fraction equal fraction. This is fraction multiply fraction straight across. Okay? Okay. So 16 square roots of 2 divided by the square root of 2 times the square root of 2, which is the square root of 4. And so the square root of 4 is 2. Can I reduce the stuff outside the radicals? Yes, I can simplify the stuff outside the radicals, and 16 divided by 2 is, and I'm going to leave the radical as is, and this becomes 8 square roots of 2. And you could say it either way. I've heard some, the people who've been commenting so far have been saying 8 times square root 2, 4 times square root 2, that's fine. You'll also hear it said as 8 square roots 2, 4 square roots 2. Or 8 square roots of 2. It's all the same thing. All right, let's do the last one, number 3 together. 45, 45, 90? Yes, because the leg lengths are congruent. Do I have those leg lengths? No, but I have the hypotenuse. So to find the leg length, I should? Divide by what? Beautiful. Am I allowed radicals in the denominator? So I should rationalize, which is a multiplication of 1. I'm going to look at the denominator to help me figure out what should be numerator and denominator of my fraction 1. What should I use? Square root 2. Because when I multiply straight across, my denominator becomes something that has a whole number square root. Can I simplify the stuff outside the radical? And that becomes 9 square roots of 2. There is a pattern. Some of you might already be able to see it. Now that I've pointed it out, you might be going, what is it, what is it, what is it? Take the weekend to think it through. Maybe play around with some 45, 45, 90 triangles with whatever kind of measurement you want on the hypotenuse. And do this a couple times. Invite some friends over. Throw a math party. Serve right triangle shaped snacks. And then see if you can figure out the pattern to make it even easier for yourself. Okay? All right. Let's flip the page. Or do you want to do these little mini word problems first? Huh? The word problems? Okay. Number 5. If a 45, 45, 90 has an hypotenuse of 12, find the leg length. Okay, so we're given a hypotenuse, we want a leg. What should we do? Divide by?
Square root of 2.
All right. Hypotenuse divided by square root 2. Can you see the pattern from here? Right, we're going to rationalize. Okay. I'll let you finish it out. You don't need to see more? Okay. Shall we do number 6? At least the setup. Determine the length of the leg of a 45, 45, 90 with hypotenuse length 25. Am I given hypotenuse or leg? Hypotenuse, so what should I do? Divide by square root of 2. Again, we're going to have some sort of rationalization happen. This is really easy to overthink, right? Because it's so simple. Remember, this one only works if you have a 45, 45, 90. So the question becomes, what if you don't have a 45, 45, 90? Well, there's only one special kind of right triangle that it could possibly be that could help you out, and this would be the 30, 60, 90 right triangle. If the first special right triangle was 45, 45, 90, because its angles measured 45 degrees, and 90 degrees, what's the angle measures for this one? 30, 60, and 90. Okay, so the words here, I'm going to fill in a little bit because I want to start with the picture. There's the worst right triangle in existence. Okay, and I'm going to zoom in real close on the right triangle. All right, I'm going to make this, and here's where my colors come in. I'm going to make this one the short leg, or excuse me, the small angle, and across from the small angle is the small leg. Okay? There's my small leg. As always, here's my 90-degree angle, and that makes this my hypotenuse. Please make sure that I always refer to this thing as the hypotenuse and not anything else. I have a really bad habit of trying to call that the long leg. Is hypotenuse. This means that across from the medium angle of my triangle is my big leg of my right triangle. All right, here's the pattern. Whatever the small leg is, the hypotenuse is 2 times that. The small leg is 1. What's the hypotenuse? 2. Just multiply by 2. Small leg is 3. Hypotenuse is?
6.
Small leg is 40. Hypotenuse is?
80.
Small leg is apple tree. Hypotenuse is? 2 apple tree. It doesn't matter what's in there. Just multiply by 2. We're done. Yes? All right. Let's look at the big leg. The big leg is whatever the small leg is times the square root of 3. Again, said value square roots of 3. If my small leg was 1, my big leg is 1 square roots of 3. Very good. You said 1 times. It's fine. We're saying the same thing. It's okay. Small leg is 2. Big leg is 2 square roots of 3. Small leg is 40. Big leg is 40 square roots of 3. Small leg is sunshine. Big leg is sunshine square roots of 3. It really doesn't matter what you've put into the measure of the small leg. Just multiply it by the square root of 3 and you've got the measure of the big leg. Super easy to overcomplicate and make a mess. Okay, let's practice not overcomplicating it. I'm going to start with number 2. All right, here's my right angle. Which one's my hypotenuse?
Y.
Beautiful. Here's my 60 degrees, so which one's my big leg?
X.
And that means that what's left over is my small leg. Okay, my small leg is 8, so my hypotenuse is? How'd you get that? He said 16. How did he get that? Because my pattern says the hypotenuse is 2 times whatever my small leg is. Perfect. Beautiful. Small leg is 8. Big leg is? 8 square roots of 3. Because my pattern says take the small leg and multiply it by the square root of 3. Don't think hard. Number 1. My hypotenuse is? Beautiful. My small leg is?
1/2.
And my big leg is?
Y.
All right. My small leg is 1/2. My hypotenuse is 1 because it is my small leg times 2. My small leg is 1/2. My big leg is
Square root 3.
half square root 3, or 1/2 times the square root of 3. Don't put these into your calculator, please, for the section 0 decimals, unless they've been started off with. No decimals. Square roots. Okie dokie. Look at number 3. Here's my right angle, so here's my hypotenuse. Where's my small leg?
X.
And my big leg?
Y.
Beautiful. Now, I've been given the hypotenuse. To go from small leg to hypotenuse, what was I doing? Multiply by 2 times 2. So to go from hypotenuse to small leg, I should? Beautiful. And so my small leg's measure is? Huh?
5
5.5
1/2.
or 11 over 2. Leave them as fractions. Again, no decimals. All right, my small leg is 11 over 2, 11 halves. And so my big leg is 11 halves square root of 3. Is this getting ridiculously simple? Oh, very good. I'm so happy for you. Let's do number 6. Which one's my hypotenuse? Okay, and my small leg?
Y,
Good. And my big leg?
X.
Beautiful. My hypotenuse is 20. My small leg is 10, because to go from small leg to hypotenuse, you multiply by 2. So to go from hypotenuse to small leg, you divide by 2. My small leg is 10. My big leg is 10 square roots of 3, because my pattern says for big leg, take small leg, multiply by square root 3. Really easy. And I'm okay with this work. Like, this is the work. You've identified which one is which. You've got your this thing. Follow the pattern, you're done. All right. Let's look at number 4, because, oh my God, it starts with a square root in there. And, oh. Which one's my hypotenuse?
Y,
Which one's my small leg?
X.
Which one's my big leg?
9 square root of 3.
Okay. To go from small leg to big leg, what were we doing? To go from small leg to big leg, what were we doing? Small leg times square root of 3. To go from small leg to big leg, we were multiplying by square root 3. So to go from big leg to small leg, by? Divide by square root 3. So that means I'm going to take the big leg, I'm going to divide by square root 3. 3. I have square root 3 in both numerator and denominator. They're going to cancel. They're going to divide out to be a 1. Leaving me with just, there's small side. Small side is 9, so hypotenuse is, how'd you get that? Times small side times 2. Perfect, that's it. Wait, let's make it one step more complicated. Do number 5. It looks super simple, right? It's just a whole number. Deceptive. Here we go. Hypotenuse.
Y,
Short side.
X.
Long side, or big side.
12.
To go from big leg to small leg, you divide by?
Square root.
Divide by the square root of 3. I need to do what? Rationalize. So I'm going to multiply by a fraction, numerator and denominator being the same. What am I multiplying by? 3 or square root 3?
Square root.
Square root 3, because that's what I need to fill that radical in the denominator to turn the square root of 3 into something that has a whole number square root. That something is 9. And so square root of 9 is?
3.
And so I have 12 square roots of 3 over 3. Which can be simplified down to 4. 12 divided by 3 is 4. So I have 4 square roots of 3 as my small side. Deceptive, yes? But simple. All right, in order to get the hypotenuse, what should I do? Multiply what by 2? 4 square roots of 3, the small side. I heard someone give the value and I heard someone give the identifier. You're both correct. All right, so what's 2 times 4 square roots of 3? 8 square roots of 3. And I heard that question your voice because your question was, do I multiply the 2 into the radical? And the answer is no. The radical, imagine that number is inside of a house and the 2 is outside knocking, trying to get in, and it's the big bad wolf and the 3 little bears. Okay? The number 2 cannot get into the house. He cannot huff and puff and blow the radical down. Cannot multiply into the radical. What did I say? The three little wolves? Oh, three little bears? I totally mix it. That's right. Ah, this is why I don't teach English. I can't keep my stories straight. Let's do 7 and 8 real quick, because there's some words in there that might be tricky. An equilateral triangle has an altitude. Oh my God, I'm already lost. Let's draw this thing. Equilateral triangle. What do we know about equilateral triangles? What does the word equilateral mean? What's all equal? All sides, and you're right, all angles. Now, the word equilateral doesn't mean that the angles are equal. That would be equiangular. But in a triangle, equilateral triangles are also equiangular triangles. So you're not wrong. Okay. So all the side lengths are equal. All right. Has an altitude of... All right. How do I draw an altitude? Goes from a corner where? Down to the other side, and at what angle does it hit? 90. At 90. So I'm going to go from a corner, and I'm going to go down toward a side, and I'm going to make sure it hits at 90. So I have a right triangle, and potentially a special right triangle if some angles line up. Now, you had said, very important thing, which was that the measures of an equilateral triangle are all equal. What is the measure of the angles in an equilateral triangle? If they're all the same, and there's 3 of them, and they add up to 180, they have to all be 60. Because 60 plus 60 plus 60 is 180, which means this angle right down here is 60 degrees. Wait a second, what kind of triangle is this?
60, 80, 90.
A 30, 60, 90 right triangle. Here's my hypotenuse. Here's my small side. Here's my big side. Legs. Excuse me. My small side, my small leg, and my big leg. I'll turn it in a bit. All right. Okay, my altitude was this one, and it's got a length of 36 feet. So this right here is 36. My big leg is 36. They want to know the side of the triangle, which is my hypotenuse. I need my small side to get to my hypotenuse. To go from big leg to small leg, what do I do? Divide by square root of 3, which I'm going to rationalize. I skipped writing a few steps in there, but the process is the same as up above. All right, that's my small side. So if this is my small side, what's my hypotenuse?
12 square root of 3 times 2.
12 square root 3 times 2. Which means my hypotenuse is 24 square roots of 3. Number 8's exactly the same. They just changed the number from 36 to 45. Just like in the 45, 45, 90 right triangle, when we're doing that division with the radical, there's a pattern here. And like the 45, 45, 90, I'm not going to tell you what the pattern is. I'm going to let you add this to your triangle party that you're going to do over the weekend with your friends, I'm sure. And you're going to try to figure out what this pattern is. If you don't find it, I will spoil it on Monday. But that's all that I had. Thank you.